All right, so this is part 3, 6.1. We're still talking about solving equations using inverse or opposite operations. A lot of the same stuff. We're going to have some examples where we have decimals and fractions and things. So I don't know how many of you like decimals or don't like decimals. I know that fractions generally is a bit of a, students don't like fractions so much. I'm not sure why. But decimals, I think, are a little bit easier if you have a calculator, you know, to figure out decimal things. It's a bit easier. But anyways, let's take a look at some word problems here. So, two different taxi companies charge the following rates. So, company A is $3 plus $0.2 or 20 cents per kilometer. So, it's $3 plus $0.2 per kilometer. Company B is 2.5 or 250 plus $0.25 per kilometer. So this is cents, but it's helpful when we're writing an equation that all of the quantities should be in the same units like this. So it should be dollars and dollars. So you don't want to put dollars and then cents in the same equation. Okay, don't do that. That just gets too confusing. You're going to get the wrong answer if you just plug a number in. So it has to be the same unit. So that's why they write the cents as, you know, dollars. Okay, at what distance will the cost be the same? All right, so you should probably know that this is going to be a linear equation, all right? The relation for company A, the cost for company A, is going to be 0.2 times the kilometers, we'll say that's K, plus a $3 charge, okay? So 0.2K plus 3. And company B over here is going to be 0.25K plus 2.5. So these are linear relations. These are straight lines, okay? And we don't have to graph them, but if we did graph them, one of these graphs would be, you know, starting at 3, and it would go up, 0.2. So I'm going to estimate 0.2 about there. B, that's A. B would look like this. It starts at 2.5, so that's a little bit lower, but it has a sharper, or it has a higher slope. So it's actually going to look like this, right? And it's going to cross over this line at some point because it's got a steeper slope. So graphically, I like to visualize things graphically. You can see that there's going to be some point where these straight lines cross, where they intersect each other. And this question says, at what distance will the cost be the same? So graphically, we can see that there's going to be a place where the total cost, which is this total cost right here, right, the total cost, is going to be the same. So at some kilometer distance, they're going to be charging the exact same amount. So algebraically, how we would do that is we'd say, so this is cost for A, this is cost for B. So when the costs are the same, that means that the relation that they equal will also be the same. So where is cost 1, this is cost 1 for A, and cost 2, where are they the same, right? Well, we find that out by setting each of the relations equal to each other. So we're going to do this. We're going to do 0.2K plus 3, and I won't put the decimals there now, the zeros, just to simplify, and 0.25K plus 2.5. So we let those relations equal each other, and the K value that we solve for, so whatever this K is going to be this kilometer distance that relates to the identical cost. Okay? So we let them equal each other. And now we do everything the same that we did before. So we have some decimals, so no problem. You can take the smaller one over to the bigger one's side. That will keep the term positive, but you don't have to. You can always take the variable to the left side if you like that better. So I'll do that because I think most students like that. Just get the variable to the left side and the constant to the right. So I'll do a different color for this. Let's subtract 0.25K from both sides. And I'll just do one step at a time. So 0.2K minus 0.25 is going to be negative 0.05. Okay, and then plus 3, these are now gone over here, equals 2.5. Whoops, where'd my K go? Okay. Good. Now, next step. I'm going to get k by itself, so let's subtract 3. And that's going to give me still negative 0.05k. Make sure you write everything, every line, write everything down again that you don't touch, okay? Some students just maybe just write part of the equation in the next line and kind of don't rewrite the whole equation, but rewrite the whole equation. It doesn't take you much time. It'll just be less opportunity for you to miss something, okay? So these are gone, and 2.5 minus 3 is negative 0.5. Okay, I'm running out of room a little bit here. You probably aren't, but you should have enough room there for this. But so now the last thing I got to do is divide by negative 0.05. Okay, and so I'll finish up over here. So that's going to give us just k on the left side, and this is 0.50 divided by 0.05. So that's the same as 50 divided by 5. See that? It's like 50 divided by 5, which should be 10. You like that? So at 10 kilometers, cost is the same. At 10 kilometers, the cost is the same. So if you know you're going to go a very short distance, then you're probably going to want to do company B. You'll owe less. But if it's going to be more than 10 kilometers, company A becomes cheaper then. Okay. Any questions about that? Scanning the room, no questions? You sure? All right. Okay. Example 2, this is about an internet company, offers 2 different plans. So plan A, there's no monthly fee, which would be your flat rate, but it's $0.75 per minute. So let's say plan A's cost is going to be 0.75 M. Plan B's cost is going to be a $15 monthly fee. So we could write 15 there plus 0.25 per minute. 0.25 M. So these are two different rate plans. I'm going to give you a minute to solve this. So do exactly what we did in the first example. Go ahead and see if you can do this on your own. Find out how many minutes it will take for the companies to have the exact same charge. Okay? Because these have different slopes. So and different y-intercepts. So they are going to cross over each other. So go ahead and take a minute and do that. You're on your own. Solve for M. Okay, so what you want to do is let each of the equations equal each other. So I did that over here. 0.75 M equals 15 plus 0.25 M. And we'll get the variable over to the left side. That is the smaller one. Bring it over to the bigger one too. So that's going to give us a positive value when we're all done. So that's great. So subtract 0.25 M from both sides. 0.75 minus 0.25 is 0.5 M. Equals, what's left over is 15. Divide by 0.5. Now when you divide by 0.5, it's same as multiplying by 2. So 15 divided by 0.5 is 30. So M equals 30, which means that at 30 minutes, the cost will be the same. Who got 30 minutes there? Anybody? Okay, good. Good job. Any questions? Oh, am I still frozen for you? Oh, there you go. Okay. There it is right there. Sorry. I thought I had that unfrozen. So yeah, here it is right here. 30 minutes. Any questions? All right, let's take a look at example 3. In this chapter, in this section especially, when we're talking about these kind of linear equations, some of the word problems talk about sales or taxes. So you're going to have to find the percent of a number. And so I just want to do a couple questions just to kind of remind you how to do that. So how do you find a percent of a number? Well, if you have to take or find 15% of 100, does anyone remember what the process is to find 15% of 100?
Turn it into a decimal and then times it by
Yes. Yes, very good. So you take the percent and you make that a decimal. So the decimal form of 15%. you take 15 and you divide it by 100. That's what percent means, per 100. So really 15% is 15 over 100, is per 100, which is a decimal of 0.15. The easy way to remember this is just to move the decimal place over 2 times and plop it down, so 0.15. So we're going to change the percent to a decimal, good, and then we're going to multiply by the number there. So 0.15 times 100 is equal to, well, when you multiply by 100, you move the decimal place 2 times to the right. There's 2 zeros and 100. That's an easy way to remember how many times you move that decimal place. So we have now 15, and the units are dollars. Good idea to put 00 for cents too. If you're talking about money, please go to 2 decimal places, okay? Because we're talking about cents. You don't have to go to 3, and you shouldn't really just stop at 1 or none. You should put the 2 decimals there. Okay? So that's $15. Everybody got that? Okay? That's excellent. Now, this one says sales tax of 11% is charged on a new bunny hug on sale for $45. Bunny hug. Yes, bunny hug. It's a Saskatchewan word. We have to keep using that. Okay. What's the total price of the item? Now, this is a different kind of question. And you can do this 2 ways. So I'm going to split this up into method 1 and method 2. One might be a little more familiar and straightforward. The other one is quicker, but not too hard to understand. So method 1 would be to find the percent, find 11% of $45 first. Okay, that's method 1, step 1. And so we would go 0.11, and make sure you're writing this down because I want you to have a record of both ways here. Sorry, times 45. Okay, that's step 1, which equals what? Anybody done that? Yeah, make sure you guys are writing this down, okay? This is for you guys. I know how to do this already. So, all right, okay, thank you. 0.11 times 45, I'll just show it up here, is 4.95, okay? So that's 4.95. So step 2 would then be to add the tax to the price. No problem. So 4.95, that's dollars, plus $45. And that's going to be $49.95. Okay? Good with that one? Now that's step 1. That's kind of a 2-part step. Find the tax, add it to the original price. Method 2 combines those 2 steps. Method 2 combines those 2 steps. And this is one you're going to want to learn. So I'll do this one in black. So method 2 in black. What you want to do is, if you have 11% that you're adding on to something, then turn 11% added to price. Sorry, it's a little messy there. Turn 11% added to price into 1 decimal. Okay, into 1 decimal. So that would be 100% plus 11%. So this is going to be the whole price in total with 1 step. So 100%, you're going to have to pay for the item. Here's 100% of the item. And then you want to add 11% tax onto that. So that decimal is going to be 1.11. Okay? So instead of just finding the tax and adding it, we're going to find 1 decimal and multiply it by the original price. So multiply new decimal here by original price. So that's going to be $45 times 1.11. And when you do that, you basically save a couple steps. Look at that. So it adds them up for you. So it's really half the work. You just have to kind of understand that, you know what, I'm going to add the 100% as well to that decimal place. So that's $49.95. And so if you If you want to find the exact price of something that you're going to buy at the store, then you can just do that. Whatever the sales tax is, if it's 11%, 1.11 times whatever price you see on the tag, that's the total amount of money you're going to spend on that. Okay? All right, any questions? Whoa. All right. Next page. We've got about 12 minutes left here. Let's see if we can do it. I think we can. All right. So solving multi-step equations. We've done this already before. We've already solved equations using the distributive property. We've already done fractions before. We've already done variables on both sides. So if we had to do all these in one equation, should be no problem. Okay? Should be no problem. This is a question that you'll see here now. That's one of the more complicated questions that you'll have to solve. But you simply do all the things that we've learned and you just put them all together. So distribute, okay, deal with your fractions, eliminate denominators if you need to, and variables on both sides, you just combine like terms. So this one, I'll zoom in for you at the back. So we're going to distribute that 3 inside those brackets. That's going to be 3x plus 3. Distribute the 2 inside the brackets. That's going to be 8 minus 2x. You see that? So distributing, check. Variables on both sides. Well, let's get everything over to the other side. So let's add 2x. Add 2x. I'm going to do 2 steps at once. For those of you that can handle that, I think you can. I'm going to get rid of the 3 over here, and I'm going to take it over to the other side. So I'm going to subtract both sides by 3. So these are canceled out and gone, and these are canceled out and gone. Which leaves me with, I have to simplify 3x plus 2x. I have the equal sign, and I have 8 minus 3. So that's what's left over for me. So 5x equals 8 minus 3 is 5. Wow. Now we're on the home stretch. We can see the finish line. Just divide by 5. I get x equals 1. Check. So I do want you to check your solutions here, which we didn't on that previous page, but I'll get you to go back and check those solutions as part of your homework for the phone company and all that problem. Put those values in and show the check that it actually does work. Okay, so I'll let you guys check those answers. But again, this is how you check this. So you just put in 1 in wherever you see a variable, and we're going to just evaluate. So that's 3 times 2. This is 2 times 3. Well, that's 6, and that's 6. So that works. Okay, and just before I forget, so please add a check to this one, and a check to this one as well. Okay, so don't forget that. Add your checks there. That'll be your job. All right, let's take a look at this fraction 1. Okay, fraction 1 looks tricky, but no, let's just do all the steps. First thing we're going to do is distribute. So that's going to be 1/2 x, or you can write that as x over 2. It's the same thing. Minus 1/2 equals 2/3 times 1 is 2 over 3. 2/3 times negative x is minus 2/3 x. So like I say, it might be easier for you to write the x's as multipliers on top, which I'll show you what that looks like. This will just look like x over 2. This one would look like 2x over 3. So you can leave that x on top if you want. And I kind of like this better because there's no question as to whether that x is on the top or the bottom, you know. If it's on the side, it's like, oh, where is it again? So it should be on the top there. Okay, so what's my lowest common multiple here between 2, 2, 3, and 3? 6 is absolutely correct. All right, because we have 2, 4, 6, 8, and so on. We have 3, 6, 9, and so on. So there we go. 6 is the smallest number that's in both lists. So I'm going to multiply everything by 6. And you can actually just do this as a shortcut. You don't have to write 6 beside each term if you don't want to. But really it means the same as multiplying every term by 6. So I don't want to show you too many shortcuts because I don't want you to lose focus on what you're actually doing. But you're multiplying 6 by every single term. So you don't have to write this step out if you understand what's going on, but this is actually what's happening, right? So I will write it out because it doesn't take long. But you have to multiply 6 by every single term here. All right, and that's what this means. So if you just write this 6 with the brackets over everything, okay? Now 6 over 2 is 3. That's 3 times x. This turns into 3x. Okay? 3x. 6 times 1/2 is 3. Equals 6 over, that should be a 3 there. I don't know why I wrote a 6. Talking. So 6 over 3 is 2 times 2 is 4. And 6 times 2x over 3, so 6 over 3 is 2 times 2x is 4x. So, just to slow that down a little bit, if you simplify the fractions, a number on top and a number on bottom when you're multiplying, that's 3 over 1, so 3 times 1 is 3. This 6 over 3 is actually 2 over 1, so 2 times 2 is 4. Okay? And if you show it this way, you just have to kind of distribute this to each term and simplify a little bit more mental math. But that's up to you. I'm not sure. You might make some mistakes here if you do this. So I would still suggest that you show this line of work. Probably still be a good idea. Okay, so you don't make any mistakes. All right, let's keep going. Now let's add 4x to both sides. Add 4x. Let's also add 3 because I want to get rid of this minus 3. So these are gone and these are gone. And my answer becomes here now 7x equals 7 divided by 7, x equals 1. Any questions? And you can check that by putting 1 in for x and seeing if the left side equals the right side, which I will leave you to do the check on your own. We're almost done here, and class is almost over. So I'm gonna do well. Actually, I'm gonna get you to spend the last few minutes doing C on your own, and I will show you the answer to C at the end of class. So we just have a few minutes left. Try and do C all on your own. Okay, C all on your own.